So we're now going to look at another numerical method. We're going to look at fixed point iteration, and this involves rearranging our equation in a way that you will be used to from GCSE. So the notes that I've just got on the page here just give you a general overview of what we're doing. An iteration or iterative process is a method of generating a sequence of numbers by repeating the same process over and over again. Fixed point iteration can be used to find an approximation to a root of an equation. An equation f of x equals 0 is rearranged into the format x equals, and this provides the basis of an iterative formula. By using a sensible estimate for x, the iterative formula can be used to generate successive values that converge to a closer approximation to x. So we're going to look at an example. The equation we're going to look at is 8x cubed plus 11x squared plus x minus 1 equals 0. And I've rearranged it in three different ways. First of all, by taking the single x term and keeping that on the left-hand side and moving all the other terms to the other side. And the second way is to isolate the 11x squared and then divide by 11 and square root. And the third way is to isolate the 8x cubed term and then divide by 8 and cube root. So the algebraic way of going from the equation to those three different iterative formulae should be pretty straightforward. So we're going to find the roots of the equation 8x cubed plus 11x squared plus x minus 1, and we're going to use the rearrangement that's shown here. The x equals the square root of 1 minus x minus 8x cubed all over 11. At the top of the page, the first of the two graphs, we have got y equals 8x cubed plus 11x squared plus x minus 1. And you know that the roots of the equation that we're trying to find are situated where the graph cuts the x-axis, and we have three roots. They're in the intervals -2, -1, -1, 0, and 0, 1. So what we can do is we can actually then draw the graph at the bottom, and the rearrangement that we have got here, we can then say, well, if we were to draw the two graphs, y equals x, which is y equal to the left-hand side of that equation, and y equals the square root of 1 minus x minus 8x cubed all over 11, then we could find the points of intersection, and that would give us the roots of the original equation. So the axes on the two graphs are exactly the same, they're identical. So you can see that if we were to go to the left-hand root, and that's in the interval -2, -1, if we draw a line down to the graph at the bottom, it goes down to the intersection point of the two graphs. The central root in the interval -1, 0, again can line up with a point of intersection of the graphs y equals x and y equals the square root of 1 minus x minus 8x cubed all over 11. And the same happens with the third root, that they are identical values of x. So what we can do is we can use the iterative formula. The general formula is given at the bottom of the page, which is that each successive value of x is generated using xn plus 1 equals the square root of 1 minus xn minus 8xn cubed all over 11. So before we look at how this works graphically, we're just going to look at the use of the iterative formula. We're going to have that x0 equals 0. We're going to find the root in the interval 0, 1. And we're going to generate x1 by substituting x0 into our iterative formula. And so the table on the right-hand side is an Excel spreadsheet. The first value of x is x0, and that's our 0 here. And we are going to then substitute that into our iterative formula. and that will then generate xn plus 1, which is x1. That is then transferred across, and so x1, you can see those two values on the table are exactly the same, and x1 is then put into our iterative formula, so that x2 is generated using 1 minus x1 minus 8x1 all cubed all over 11 and then square rooted. And if we then substitute in x1 into that formula, we then generate x2. And you can see from the table that the value of x2 is 0.208720709, and that is x2, which is then transferred across and substituted in, and so x3 is then generated. And you can work your way down this Excel spreadsheet and try and find your root to a certain degree of accuracy. So we're going to see whether we can get this root to 5 significant figures. If you were to look here at x9 and x10, you can see that they're not the same to 5 significant figures. However, once you get down to 14 and 15, then you can see that x14 and x15 are the same to 5 significant figures. It's worth checking the spreadsheet as it goes on down, because sometimes the iterative formula can give you the impression that it's actually getting close to a root when actually it still has a little way to go. But we can see that actually it is going to be the root from iterations 14 and 15, and that the value of x is 0.24205 to 5 significant figures. And that is found using 15 iterations. 14th iteration gives it, but the 15th iteration is required in order to confirm exactly what the root is. Now we're going to have a look at what this means graphically, and so we're then going to have a look at the graph that we had on the previous page. So here's our graph. We've got an x0 value of 0, and what we do is we then substitute that into our iterative formula. And if we were to draw a line up to our blue graph, sorry, that's not a straight line at all. Let's draw a nice straight line. So if we draw a line going up, then it joins the blue graph at the point x0, and then it joins at the y coordinate, which is x0 substituted into our iterative formula. And what we want to do is to transfer that new y coordinate to our x coordinate. And we can do that graphically by going horizontally and moving across to our y equals x line. And what we have there is we then are going to have a point, and the coordinates at that point is now going to be our x1. So because it's on the line y equals x, our x and y coordinates must be the same. And because we've moved horizontally across, then our previous y value, which was generated using our iterative formula, because remember this graph, the blue graph, is y equals our iterative formula. And so what we've then done is we have generated x1. Now, because that graph was a bit small, I've now focused in a little bit more on this root. So this is the same graph as before, but we just zoomed in on that particular section. And you can see exactly the same thing has been done. We've started off with an x0 value of 0. We've drawn a line up to meet our blue curve, and then we've moved across horizontally to y equals x. And you can see that if you were to look at roughly what that value is of x here at this point, if I draw a line down, then you can see that it's just over 0.3 as a new x value. This is our x1, remember. And this is confirmed by our table on the right, which has our x1 value as 0.3015, so just over 3. So what we want to do then is we want to take that as our new x value, so that's our x1, and we want to substitute it into our iterative formula, i.e. we want to know where that x value hits our blue curve and what the value is when we substitute it in to 1 minus x minus 8x cubed all over 11. So what we can do is we can actually look at this point here, because that's the point where our y equals x, we go down from our y equals x line to hit our curve. And this is now going to be the point x1, y, and that y value is the value that we want to be our new x value. So again, we're going to do the same as we did before. We're going to move across horizontally to the line y equals x, and that will transfer our y value across so that we now have the same x and the same y value, and the coordinates at this point are going to be our x2, x2. Now again, from our table we can see that the value of x2 is given as 0.208720708, and that is confirmed by the graph because it's just to the right of 0.2. So what I've done is I've continued the same process of transferring each x value, so x2 is then transferred into the iterative formula, which means that we then move to the blue curve and then generate a new value of x, move across to the y equals x line so that that new value of x is taken. And we end up with this lovely cobweb diagram. And the reason why it's called a cobweb diagram is because it's sort of wrapping itself around the root. You can see that we're actually going from one side of the root to the other. And the successive values of x, so our value of x3 is going to be around here. So this is x3. And then the value of x4 is here. And you can see from our table that x3 is slightly higher than our root, whereas x4 is slightly lower than our root. And then the same process would keep going as we move around and around the root, getting successively closer and closer and closer. On the previous page, when we had the whole spreadsheet, we said that the root was 0.24205, 25 significant figures, and we're just going to verify that. Our error bound is plus or minus 0.000005, and so we are going to find the values of f of 0.242045 and f of 0.242055, and we're going to substitute those in to our original equation. I'm going to take f of x as being 8x cubed plus 11x squared plus x minus 1, and you can substitute those values in and see what you get. So you should have got that one of those values of f of x is negative, one is positive, and therefore we have a change of sign, and that confirms that the root is as we thought.